Let's say we have a data set here and we would like to see if the mass, say, of salicylic acid that was weighed out for lab group A on this lab day, they were supposed to weigh out 5 grams. And what we'd like to do is see if the mean of this actually matches the 5.0000, 4 decimal places, that's expected out of that weighing. And so what we can do is we can call in this data, call in the CSV file, create a data frame of each one of these columns, specifically select this one, get rid of any null values because the t-test won't work on them. And then we can group by with the A function, or sorry, with the A lab day here, get the mean of this and do the t-test and compare it to the value of 5.0000 and see if the mean is the same or not. So it's a way of comparing our data to a known value. Where this comes in handy, if we've got an expectation, say for the mass that's going to be produced, or say the melting point that we're looking for, or the amount of the recrystallization, we can compare the value to a known value and see how it goes. So we've got code here that I developed with the Copilot, and we import pandas as a PD, we import SciPy, and so we read in the CSV file that we just had there. We're going to drop any null values, specifically from the mass of salicylic, not from any other column because I don't want it to affect it too much. We're going to group everything by lab day. So now we've got all our data set grouped by A, B, C, D, and so on. And now we perform the statistic on it. And since we're doing it versus a known value, this is a one sample t-test. And so what we're asking it to do is to calculate the t-statistic and the p-value for it based on this function. The function is going to take the group set A and the column mass salicylic specifically for that. That's going to be the data set that it will compare against our value here. So if we were to have, for example, melting point data for something, we could actually say for the specific lab group or for the year or whatever we wanted of the melting point of a specific one. It could be pure ASA, it could be crude ASA, it could be pure salicylic acid. And if we have a known value or expected value for that, we could put that in there and then see if the value for the class actually matches that known value. And finally, we're going to print out the value and we're going to do it to 4 decimal places here. So that's what this does. So print the p-value to 4 decimal places. Otherwise, it'll print like 8 or 12 decimal places. And then we'll put in this little code here to help us out. So the p-value is the one that we care about. This is a two-sided. And so if we wanted to have it as a one-sided, we would divide the p-value by 2. Anyway, it's a two-sided one. And so if our value is less than 0.05, then we reject the null hypothesis. Otherwise, if it's greater than 0.05, then we're going to say they're equal. And the hope is that everyone who weighs out this stuff is going to weigh around 5 grams. But the fact is, when we run this, we're actually getting a p-value that is 0.0124. So it's close. It's getting close to the 0.05, but it's not there. It's not there. So statistically, we can't say that that average right here, we cannot say that the mean here is the same as 5.0000. And so it would beg the question, why? Why is this different? And so it seems that these students, when they're weighing their stuff out, everyone just weighed slightly less than what was needed. If we were to do a value on the entire data set, I'm curious if we would get closer or if we would actually see that, yeah, on average with the larger data set, we are hitting that value. Maybe we're not. It would be interesting to see what would happen of this value compared to all the other lab days as well and see which one actually kind of hit the target. But in the meantime, this is it. We can just do our data set versus a known value, and this is how you do it. So one of the things we were thinking of doing was being able to do a t-test against a known value. And we can do that with the one sample t-test here. So using the lab group A and do it against a value. So in this case here, the weight of salicylic acid that was supposed to be weighed out is 5 grams. And so what we're doing is we're pulling in the CSV file, we're creating a data frame, we're dropping any null values because the t-test doesn't like that, specifically on the mass salicylic column so that the rest of the values don't get edited. And we're going to group by lab day. So A, B, C, D on the lab day. We do a t-test with the p-value using this stats function that we imported from here. And we're going to just specifically do it on lab group A. So if we want to do it on lab group B versus this, or lab group C versus this, then we can just apply that. And we got a nice little sort of thing here that tells us if it actually is equal or not. And so for this case here, um, it says here we reject the null hypothesis that the means are equal. So it's reject opposite of this, so they're not equal. So this day A, this lab day A, the average values that they got were not equivalent. But let's say we wanted to see if all the means were equivalent to this. Well, an ANOVA can't really do the work for us. It's actually trying to convince or trying to do mean versus mean versus mean, and it just really gives you the idea like, are they the same or are they not? And we can start to use Python to our advantage here. So we can create a for loop that will allow us to actually cycle through this exact same thing, but for each one of these lab days. So we can now go lab day A, lab day B, lab day C. So for everything in the grouped lab day, we can cycle through this and compare it to the value 5 and spit it out. So I'll show you what that looks like. So over here in this one, again, I used ChatGPT or Copilot to do this, but it's essentially the same thing. So I'm going to read in pandas and SciPy. I'm going to read in my data frame here. I'm going to drop anything from the set mass salicylic, and I'm going to group by lab days. So this is exactly the same as we've got so far, right up to this point. Now here is where our equation is. So we do have our equation, but it's now in a for loop, like I said. So for lab day in grouped, t-test and p-value, so they're going to do the calculation on mass of salicylic. So for each one of these in the group, so for this value here, group of mass of salicylic, so to be A, B, C, D. So because we've grouped it right here with this variable, so for group in grouped, so A in grouped, B in grouped, C in grouped, it'll go through and do a calculation versus this. It will compare it to, it'll print out the lab day specifically, and it'll tell you what the t-test or t-stat and the p-value is, and it'll actually tell us for each one of these whether it is correct or not, whether it is the same or not. And so here we go. The output is for lab day A, the t statistic and the p-value were this, and so it says we reject the null hypothesis that the means are equal, and so on and so forth. And we can see that some of them are actually, the means are the same. So in this case here, the mean here is the same, the mean's the same, and so on. So we got a variety of things. In our ANOVA video, I kind of told you that when we run the ANOVA that we can't see which one of these means is different. The ANOVA just tells us that something in there is different and not all the means are equivalent. Here we can do a for loop and actually see which ones are equivalent to the value that we're looking for. So even if we had a mean here, if we determined a mean for this using real data, we could input that data here even with the standard deviation, and we could have this go through and do its own t-test based on the calculated value that we found, and see if it's close or not. So there's a potential that this with the for loop becomes very, very powerful and really super easy for us to figure out what one of these are equivalent and what one of these are not equivalent.